Fish code, efficient extraction of contextual information from phishing email. Parents audio. I use this mic.
Hello, everyone. Thank you for making it back so much. Appreciate it. My name is Nalini Saka, and I'm a PhD student from the University of Edinburgh. Before I start, I'd like to acknowledge my wonderful supervisors and co-authors, Dr. Nadine Komchian from Edinburgh and Dr. Cameron Ye from Waterloo. So the paper I'll be presenting is called Fish Coder, Efficient Extraction of Contextual Information, Phishing Emails. Just so we're all on the same page, phishing is a type of cyber attack in which attackers send spoofed messages impersonating legitimate organizations to trick individuals into either giving sensitive data like some login credentials or tricking users into installing malware. This is an example of a phishing email that pretends to be from Netflix, and it has the right logo and structure similar to the one you'd actually get from Netflix. But when you look closer, most phishing emails contain certain cues that humans pick up on or to varying degrees. For example, the subject line is long and confusing and actually doesn't even say Netflix. The sender domain is not from a Netflix domain, and so on. Now, in recent years, phishing has grown significantly in scale and sophistication. This graph, pulled from Google Safe Browsing, shows you the number of active phishing sites from 2007 to now. And as you can see, in late 2015, there has been a constant increase in the number of active sites and an exponential rate reaching all-time high currently. In fact, in the year 2023, the Active Phishing Working Group observed 5 million phishing attacks, which is the highest they have on record. And 83 and recent phishing kits also come with a way to bypass multi-factor authentication, one of the standard recommendations to protect yourself against phishing. Now, what do you do as an organization to protect yourself from phishing? Most frameworks and recommendations say that we need to have a multi-layered approach. This one, recommended by the National Security Center of the United Nations, recommends having 4 layers, each one important in different ways. The first one to stop attacks. The second one is to help users identify and report phishing. Third is to protect against undetected phishing attacks, again, like MFA. And fourth is to have a system in place to respond to incidents quickly. Now, there are other frameworks that you could use, but they all recommend having multiple layers and multiple approaches. But when you look at the scale of the problem you're thinking about, you realize that we're not talking about a few dozen emails, we're talking about millions each year. And depending on the size of the organization, you're talking about IT staff having to handle thousands and tens of thousands of emails. And doing this manually is no more possible. So research has been towards integrating AI and automation into your cybersecurity practices, even for phishing mitigation. According to research by IBM, organizations that use AI based security approaches or automated security approaches experience almost half the cost of identifying a data breach, and the time taken to identify and contain a data breach is also much faster. So basically, you're having security which is cheaper and faster. But AI and automation just really high level terms, right? When you're trying to make AI work for your domain, there is a lot you need to do before you can actually work. Because an AI model, anything requires an input that gives out an output. In the case of phishing emails, the input could be headers in an email, which are great because they're wonderfully paired key value pairs. You can parse them, you can put them in. But the main chunk of context that's in an email is in the email text, which is quite tricky to create an appropriate input representation out. For example, sorry, these 2 emails from the Nazario phishing dataset. They're both from pretend to be from financial organizations asking users to download an attachment. They show you the spectrum of variation that phishing emails can possibly offer. The one on the right is NetBanks, and it's a little more sophisticated emails. You can see there's formatting, structure, logos, references to World Wildlife Fund. And then on the one on the left has 3 words. That's it. Now, these three emails pose different challenges to an algorithm, but together they're even a bigger challenge because we're expecting one model to somehow handle this much variation. I think we did the math, but one of the right has 17,000 words, and quite a lot of unnecessary, irrelevant context. So how, and research has shown that text representation models actually struggle with dealing with very short and very long documents together. That's why we have this whole research field in NLP that deals with only Twitter research, which is short text documents. The second problem we have is what does it mean by context of living text? Because machines read things differently than we humans do. When we open an email, we see certain cues in the email that machines automatically can. For us, context in an email means who is it from? What is the problem they're claiming? What are they asking you to do? You just pick up on these things that, it just comes so naturally to us as humans. But how do we break it down and make the machine replicate this thought process? And third, in case of cyber attacks like phishing, we have what we call an active adversary. It's constantly trying to find ways or find false fear detection algorithms. For example, this is an email that my supervisor got a couple weeks ago. For those who don't know, the NHS is the National Healthcare Service, primarily healthcare provider in the UK. Now, when you see the email and open it, this is what you see. But if you were to remember to parse the email for this first, it's more translators, but this is what it can parse. What happens is that attackers have whited out text. This is one of many of the methods they use, where they have whited out text at the bottom of the email or the back, so that any filter or any algorithm that was that text-based filtering would be tricked by this. So how do we make the machine focus on the correct context? How do we say ignore all this irrelevant stuff and focus on what's important? So in my previous research, we realized we need to formalize what we mean by email context. So we conducted a qualitative study to create what is called a phishing model. Papers are available on preprint if anyone wants to read it. But in this third book, we define 8 high-level contextual information that humans use when they are receiving an email. And we did the actual social but and then you first of all you have sequence to basically names. So using this as a motivation, this is what a food email would look like. The same emails, but you basically extract only the relevant information you need and basically try to standardize what you mean by context. The next step once we have this is automating it. And that is what we do information. Fish model is basically trying to emulate this human thought process to create a context representation of emails that we've not had. We've had a bunch of numbers, we have had back and forth, we've had domain tutorials, human-oriented context we've never really had. And because that's the emails are basically textual data, and we're trying to extract information from them. Language models with a normal choice. We decided to fine tune language models with mostly these reasons. First, you can fine tune it to any domain. It's been used in legal, healthcare, technical domains, and has shown impressive performance. It is a lot more efficient because training model in general requires a lot of data, but fine tuning it just requires much, much less data. It achieves faster conversions and it shows much better performance than using the model as is. So based on our codebook, we find 7 information extraction tasks. 4 of them are text classification tasks and the extraction tasks. The 4 classification tasks are from sector, which is what sector the emails to be from. Then the action generic, what action it's asking you to perform. If it has any urgency cues and if it has any threatening language. The extraction tasks are from company name, which company the email is pretending to be from. What is the specific action? Say, for example, say click to update your password data. And main topic is what will actually in place. Your password expires. Something like that. Text classification models are quite straightforward. You input the text, you give it predefined labels, which in this case are the final and it gives you a probability of visual or reachability. But with extraction, we are able to treat it, so we use question answering model because this allows us to phrase what we want as a very detailed specific question. And for example, one was based on this given context, what organization is this email from? And the context in my case would be the full email text and outputs the answering one. Yeah, very clear. So, like I said, marketing requires data much less to actually train. We use data set from two sources. The first one is the desired version data set, and obviously available for everyone to use. Please check it out. It's the set of handspring messages by the research route on the US. And we use 290 emails that were sampled, like rapidly. But when we actually analyze the data, we have very few samples of tasks. So we use the second data set from our university. We created a research inbox where staff students were allowed to delete emails that they got. They just forward it to this inbox, and we use 31 emails from there to manage these classes. So by these two, we have a final data set of 521 emails. The validation process was not easily driving one of the standard data release before strips was on classification. The three labels of the next extraction layer basically have this time you expect model to give you. We then fine tune two transformer based managed models, but you probably will be talking about the models of the last. But basically, why we chose these two models is because they can combat application. It's common sense. Now we know a bit like GPT and Llama and millions of the size of the neural network would be really this. One of the first ones, they're maximum in size, and anyone can run them on using that parameters. Then we have this simple to fine tune application and press performance in very fine tuned tasks. And they're privacy friendly because you can run them local, there is no API or there is your data can be stored. These are the results from our classification. All numbers, but basically the birds large and the birds large are better. In sense. But surprisingly, almost all of our classification tasks achieve a performance higher than 90%. And our next extraction tasks, while willing to care as well, quite impressive. Now, the exam scores are less good. We don't mind if it's not an exact match to what we want, as long as it is a unique phrase of the email text that represents kind of a us. And when we did that analysis, we realized there were very few samples of image described text, most of them had made sense to what it was extracted. Based on these results, we have some key takeaways. Firstly, fine-tuning language models and the promising approach to future researchers for fishing, and if you can think of something similar to different domains, definitely you should try. Second, individual models work better than multi-headed models. Probably we need more training data for some of the multi-headed domains. We did have an issue with class balance. That's one of the standard limitations of most machine learning tasks. To overcome the class imbalance, we realized we needed more training data and diverse structured training data from different sources. So we could overcome the class issue and also make the model more generalizable. To achieve that, we got a new data set from the Cambridge Cybercrime Center. It is much larger and it has been collecting since 2001, so pretty wide years. A lot more diverse databases being collected all over the world. And we're currently in the process of running experiments using this data. Now, apart from, of course, introducing fish meter, introducing a novel set of human-oriented features that researchers have overlooked so far, I think the one thing that I really like in our paper is we kind of give future directions that we use fish meter for. It's not that to tell you how you have this extract information, but you actually use it. So we focus in the paper and in our current research two main applications of fish meter. First is fishing campaign and implementation. Broadly speaking, a campaign, pushing a campaign refers to a large is sent together as part of a mass attack. You probably also see have almost organizations receive such attacks on a regular basis. And campaign identification has been previously used to identify spam markets, enable that, or to identify phishing web pages that share the same source code, and then basically make it done. So similar approaches could be used to identify each phishing email campaigns using almost of fish token. So basically, the one characteristic of the campaign is that the fraud is the same, the storyline is the same. So, and that's what the story does. It's the storyline. For example, these two emails, now, they're both from different organizations, but they're both from part of a similar attack, if you notice the dates. And they're both telling us okay, that the new meetings and accident was given by clients and so forth. But these two emails were identified using some of the codes we have in our workbook. But the best part about the fish cover goods is that you can define what you want and use only the features that make sense to you. The second proposed solution is user assistance. Now, it's such a show that providing real-time guidance to users is the best way, I mean, one of the good ways to improve phishing detection and also improve phishing reporting. So providing in-the-moment guidance is one of our future research focuses. For example, if someone sees an email that looks like it's suspicious, but they're not entirely sure, they have an inbuilt plugin that helps them analyze the email and give them feedback. This is just a hypothetical one. People don't get frustrated with it. But say you have an email, using this combination of fish goods have the features like significant URLs and use, you can provide more curated tailored advice to end users and improve their confidence in their decision making. And overall, they have their organization safety, improve performance and phishing mitigation, but also reduce the number of users for phishing.
Thank you very much for your presentation. Let's open for questions. Anyone have any question? Hey, thank you for the great talk. I have a question. Do you find these instead attributes, the 10 attributes or 15 attributes that you call the context, right? Do you think it is possible like to assign a way to some of them, like to say, okay, these attributes are more important than others, like in one spontaneous at the beginning of the presentation?
We are currently looking at ways because one of the future was kind of build somewhere storing this that kind of identification problem. And we're trying to come up with a way that basically whatever they needs to you can assign ways. But that again requires going through like basically sort of data and trying to come up with range. We're trying that, but everyone has different perspectives. So there could be a set of ways. But basically, how you define it, you could use data that is to, your estimate.
Thank you. Any more questions? Okay, so that's the features. So in terms of expanding the features, do you think that you can use say some metadata for emails like
Yes, absolutely. So the focus of this particular project was to formalize the text-based context. But like you said, there's a lot of data. We get this question every time I present this work, aren't you losing information when you're doing this extraction? The point is there is a lot of information like the metadata and the headers that have been historically used and we're quite good at parsing them because they're basically key value pairs. So you have to say authentication, DKIM, pass or not. It's quite easy to read. Now, how you use that information is up to you, and how valid that is was also up to the fishers. But text is something that's been everyone has kind of struggled with it because it is challenging. Unstructured data is, one of the worst things that can happen in an AI system. So finding a way to make it more structured is what we're looking at. But absolutely, you can. The thing is, this is just one novel set of features. You can add your own feature sets. You can remove anything you don't want. It's up to you. It's the flexibility. Not in this case, but so in one of the future works, we actually, for example, in the campaign detection problem, we do consider like the date of the email being received and some of the header information like the sender domain in this case. But you can add basic. The flexibility is yours.